the same, whether it is a natural system that you're studying, whether it is a socio-technical system that you're studying. And in all these cases, doing that and making a prediction to the future has tremendous socio-economic incentives, right? So that's why people want to do it, right? People want to make predictions to the future. And doing that predictions using the classical approach and the empirical approach that we were doing. In the classical approach, we try to understand how things were and then try to make a prediction. In the empirical approach, we observed what things were, made a pattern heuristic recognition, and then made a prediction into the future. Both of that combined together using high performance computing infrastructure, computational engineers, computational scientists became important, and the field of computational and data science evolved, combining the aspects of big compute and big data in putting together for several applications. Now we'll see about 4 or 5 different applications where data science, you are doing data science, right? So where you are doing data science. Let's go up to our favorite physics lab. So you all might have done this pendulum experiment, right? So I think it's there in the BSc syllabus in DU. I'm not sure, maybe it's not there anymore, but it used to be there. It's definitely there in the plus 2 syllabus, right? So 12th class syllabus, it's there. So in the physics lab, what did we do, right? We had a pendulum, it had some length associated with it. We changed that length of that pendulum, then we made it swing, and then somebody else will take the timer, right? So you will do the swinging, your friend will do the timer, and the third person in the team will make this table, right? And write what is t square. That is the time that you observe on this clock. You'll note that and square it, right? And then you will note down the length of this pendulum, right? You will change that length of the pendulum, and then you will prepare this data set, right? You are actually preparing a data set. You are doing the collection and storage process, right? You are collecting it by doing this experiment, and you're storing it on your lab notebook. Then what do you do? You analyze it, right? So you plot it, right? So the third step is of analysis you do. You plot the t square versus the t versus length, right? So you plot that, and then you do analytics. You in fact do what is called as a linear regression fit here, right? So you are doing what is called as a curve fitting. Or the parameter estimation approach, right? So you're doing an estimation, and that estimation will allow you to find this dude over here, right? Constant of gravitation, g, right? So acceleration of due to gravitation, that you find, and then you report that, right? So in your physics lab report, you will write a report saying that I found the constant of gravitation g to be 981 centimeter per second square, right? So or 9.8 meter per second square. Round it off 10 meter per second square or something like that you will do, right? The value might be slightly different in Delhi, it might be slightly different in Trivandrum, right? Because of the latitudes, all that can be there. And this process, you have just done everything that I just said was data science, right? So you actually have done it, and you are doing it, right? In many of your labs and experiments, you are doing this process of data science, which is collecting, storing the data, analyzing it, deriving some insight from this, right? So which is the constant of gravitation in this case, and communicating that result to your teacher, right? So that you have done. So this is in physics lab. So you might be wondering, right? So I already know this relationship, right? So this particular relationship I know already. So why am I making such a big deal and saying that this is all data science, right? So what is really the data science or the machine learning in this, right? So I chose this very simple example so that you know the both sides of the picture, right? One side of the picture is what is called as classical programming, or the classical side of the picture, right? So which we said was the left side, right? Which was the big compute side. In the classical picture, we said that we found rules, theories, or principles, and then we had some data, right? So this is the length of the pendulum. We had that information. You provide that rule, which is t equal to 2 pi root of L by G. That is the rule. You provide the data of the length of the pendulum and write a program to compute t is equal to 2 pi root of L by G, right? So you write a program to do this calculation, and it will output the time. It will output the time. So this is the classical approach where you have understood the relationship between the length and the time, right? So this is the relationship between the length and the time, and you simply write a calculator. You can use a calculator, or you can use a simple Excel program, right? So that you can actually use to calculate the value of the time from the length. Right, so that is the rule, right? So this is the rule that we provide, that is given to the computer or to the calculator. Calculator is also computer, right? So you give that and you get the answer as time. But in the physics lab, what you did was rule discovery. You actually did that experiment to discover that the relationship between time and length in a pendulum is t square is proportional to L, right? So t square is proportional to L. This is the relationship or the rule that you wanted to discover from data. So to do that discovery of the rule from the data, what did you have to do? You had to collect the data. That is, you collected the data, prepared that. Then you know what you are looking for, right? So which is the relationship between L and t square. This is what you are looking for. And you apply machine learning to discover this rule. The machine learning algorithm that we just applied there is what is called as a linear regression algorithm. And so that is the machine learning algorithm that we just used. So machine learning or data science is nothing but discovering the rules from the data and knowing what we are looking for, right? So that input-output relationship is known to you, the input being the length and output being the time for the pendulum to swing, that one period of that pendulum to swing, that you knew, and you tried to discover the relationship between the length and the time. That process, right? The mathematical process of doing that discovery is what is called as machine learning. Okay, in the classical, you knew that relationship, you coded that and found what the time will be for a given length. This is what is called as a forward problem, right? So sometimes in your exams, they might say that, okay, given this length and length of the pendulum, find the time period, right? So that question you might get, right? Or for this particular time period, what should be the length of the pendulum? That question also you might get. But here is given a table of time and length, what is the relationship between? That is the question which the machine learning data science is answering. Okay, we are discovering the rules. So a very simple example that we are all familiar with, physics lab experiment, in which the entire process of data science is there, right? You are doing it. You are doing it from the beginning to the end without maybe even realizing that it is data science that you are doing, right? So that thought process is what you are doing. Now let's see a little bit more complicated examples of what we see all around us, which is in finance. Right? So in finance also, in the world of finance, right? So we try to make predictive models and real-time simulations. Hello? Predictive. Yeah, predictive models and real-time simulations of market events. Right. So for example, we want to let's say I want to make a prediction of where Zomato. So Zomato recently had its IPO, right? So initial public offering, and we want to make a prediction about what the stock price of Zomato will be 10 years from now. Then I want to make a investment decision. Should I buy the Zomato IPO or not? Right. So that investment decision, for that I need to make a prediction into how the IPO will figure out, right, into the future. So that is the problem of prediction. Same as finding t equal to 2 pi root of L by G, right? So it's the same, except that now the variables of interest are the stock price of Zomato. And we really don't know what is the rule that governs how stock price changes from day to day. That rule we don't know. And we must discover that rule from data and use that rule to make predictions into the future. That is where data science comes into the picture. Right? If we knew the rule of how stock prices evolved in time, then no need of data science. Right? So then no need of doing machine learning. We can simply use the classical programming approach and make a prediction. Since we don't know what that relationship is, that is where the science comes, right? The science tells you how the relationship is. The data tells you what is that. Now using the data and the science, right? So the empirical and the classical, we are combining it together and finding why certain things happen, finding that rules and making a prediction into the future. Similarly, you all buy with credit card, I suppose, right? So, or maybe with UPI, you buy items, online you buy items. Then the important question which SBI card or HDFC card asks for, right, is whether a particular swipe is a swipe that has been done by Deepak or not, right? So has this particular, my credit card, right, it has been swiped for, let's say, 10,000 rupees. Did I actually make that purchase or not? If I did not make that purchase, that is most likely a fraud. So I must, the data, from the data, the credit card company must know what is my spending pattern and find any anomaly in that. right? So that anomalous detection of what my spending pattern is really important in finding fraud. And here, right, so there is actually no in quote unquote classical science to why a particular transaction is fraudulent. That is where the machine learning comes, which you can go do the mining of the data and understand the rules by itself, right? So that is where the thing comes. Another question, right? So, which the finance banking industry asks is how to minimize the default, loan default. How to minimize the loan default. So for that, we must collect data such as the customer profiles, what is their past spending patterns, what is their incomes, what is their age, all these things you must do, and then classify whether a particular customer is going to default or not. Whether that particular customer is going to, if he is going to default, we must increase the lending rate, or we must deny them a loan, right? So those kind of decisions, again, there is no rule behind why certain things happen, and we must allow the data to tell us the rule. That is where the data science comes into the finance world. Third is sports, right? So sports is very important, right? So in our lives, and cricket is a passion for most of us, right? So, and Olympics is going on now. So the Hawkeye decision review system is a very controversial thing, right? So we want to know whether the ball is hitting the wicket or not. So how do we know that, right? So whether, right, so that event did not even happen. Now we must make a prediction into the future as if that event happened, and then make a critical decision on whether Virat Kohli is out or not, right? So that decision, to make that decision, we must be able to make a prediction where the ball will land, after landing, where it will move, right? So that movement is required. So how do we do that? So we use very high resolution cameras around the stadium, capture images from all different angles, and a predictive model is there. A computer vision predictive model is there, which makes a prediction into the future. This is a machine learning model, an artificial intelligence model that makes a prediction into the future, right? So as if the ball went and saw, right? So that is done using machine learning. That is done using data science, right? So you use the data and discover the rule of how the ball will move, and then use that. Right? Similarly, Messi is wearing a wearable device that measures his heart rate, the exertion that he has done, all these things, so that the coach can now make a decision on whether to call him back and send a substitute or not, right? So those kind of decisions also are now increasingly driven by data, right? So the data, using the data, people have discovered the rule on whether when athlete is becoming weak and when they have to be replaced, right? So all these things are being done. Another example is healthcare sector. So typically doctors, right? So they see these MRI scans, X-ray scans, and then they say, this looks like a tumor or not, right? So whether MRI scan or X-ray is tumor or not, right? So a lot of doctors have done this in a lot of images, and now we have a sufficiently big data set from which we can discover the rules of why a certain image is why a certain image is a cancerous or not, right? So once we know that, we can then develop a computer algorithm, a machine learning algorithm that develops the rules of why a particular X-ray is cancer or not. So that discovery of the rule can be done using data science now, right? So increasingly in diagnostics, data science is being used, healthcare diagnostics. This is an example that we all know about, right? So we buy something in Amazon, immediately they say frequently bought together, right? So in addition to this particular Wi-Fi router, maybe you want to buy these other two things. So how does Amazon do that, right? It must do that at scale, right? So that is, it must do that. So whether the 63 participants that are there here, right? So all of you, if you go all to Amazon at the same time and click, all of you must get your own personalized grouping like this. So that is what we mean by scale. It is not enough that it works on one particular person or one particular geographical location. It must work for everybody who is using it, and it must work correctly, right? So that process of doing it is again data science. It involves a lot of data collection, storage, processing, analyzing, and deployment, right? So that whole gamut is there in the e-commerce world as well, right? So we have seen 5 different examples of where data science is really used, right? So I have used data science, I have used machine learning, I have used deep learning, right? So in this last example, what I mean is they actually use what is called as a deep neural network, right, to do this. So you might still be wondering, all of this is fine, but what exactly is data science, right? You must still be wondering what that is. Okay, all these examples are very good. We are all fine, but where is data science? Like, what is data? How do I explain it to somebody else? Right? So to help you do that, let's see the universe of data science. Okay, let's say that there is this universe of data science. All of data science is in this green blob that you see on your screen. Okay, so within this blob is problem formulation. You must understand what is the problem that you're trying to solve. Right? So we were trying to solve the time and the length relationship in the physics lab. We were trying to predict what other 2 items will a particular person buy in addition to what they just recently bought. We were interested in predicting where the ball will hit. That is the problem formulation phase, right? So problem formulation is an important aspect of data science. Many of the problems, right, if formulated correctly, correct problem formulation is as much a part of data science as is using the tools to solve that problem, right? So problem formulation is very important part of the data science. Then there are all these other things like machine learning, data engineering, which is doing it at scale, right? That is data engineering. Then visualizing that data, right? So observing what happened in the past. I showed you a graph of time versus length, right? In the physics lab, that is data visualization graph that we did. Submitting a record or report, right? So that is what the data stories aspect is, right? Which is telling what the data, telling the story what the data just told you, right? So that is the insights which the data gave, how to convey this insight to the other person, right? So that is the aspect of the data stories. And then IoT, right? So Internet of Things, what that means is that one of the main reasons why data science is very popular now is this idea of Internet of Things. What we mean by that is everything is smart now, right? Your watch is smart, your TV is smart, your phone is smart, your home is smart, everything is smart, and people are becoming dumber, right? Many people say that, but all these items are smart. What does that mean? They are all internet connected devices. They collect a lot of data, and this data is available for analysis, right? So it's collected and stored. Somebody has done the hard work of collecting and storing the data. Now it is just about analyzing them. So that is why these IoT smart devices are very important in the whole field of data science. And machine learning is just one subset of this entire field of data science. Okay, machine learning is just one subset of it. Within machine learning is one particular way of making prediction, one particular machine learning model that is called neural networks. Okay, neural network is a subset of machine learning, and it's one particular method of doing machine learning. Now, I also spoke about big data, right? So all of this, what I just described, can be done with small data also. You don't really need a lot of data to do everything that we just described. But when big data comes, it intersects with a lot of other things, right? So it intersects with a lot of other things. And the intersection of this big data paradigm, that is doing neural network or machine learning on big data sets, right? Doing that intersection of machine learning with big data, and particularly using neural network to do this, right? So using big data to make predictions using neural network, that is called deep learning. And neural network is, we don't have too much time to go into that, but neural network is simply a model. And the deeper that model is, that is why it is called as deep learning. There is nothing other than that, right? So it's that there in this, right? So that is deep learning models. Now, artificial intelligence, right? So AI per se, right? So is kind of independent to the field of data science. You can say AI has been there for a really long time, even before the advent of what we call as data science today. And AI can be done without data also, right? So it can be a rule-based system, right? So whatever we programmed as a rule, that can be AI. But if AI is done with data science, that intersection is what is called as machine learning, really. right? So in other words, data science is an umbrella term, right? So that puts into picture all of these multiple aspects of the field of data science. And computational data science, right? Computational and data science is doing all of these using high performance computing, right? So this is what we already have described. So this framework of seeing data science as an umbrella term with machine learning being a subset, neural network being another subset, and using data, big data to do that, that is what is called as deep learning. Okay, so we described what machine learning, deep learning, and neural networks are machine learning, right? So why is data science important now, right? I also already said IoT, right? So Internet of Things that and internet-based companies that are generating millions and billions of data points per minute. In 2019, it seems per minute on the internet, Google generated about 3.8 million search queries, right? Facebook did a million accounts, right? So logging in, people logged in 1 million times in 1 minute, right? So that much was there, and millions and billions of transactions happen, right? So on a day-to-day basis. So all of these digital